Smoke weed every day.
Hello, and I'm sorry. Alright. Let's see. Hey guys. This is, off to a good start. Let's see. What do I need to do to prepare for the stream still? My chat set up. It's been a while since I've done this, so I'm super unprepared. I had to install OBS on my system again. It's been that long. Let's see. You can kind of see my room's a little bit of a mess, but it's nothing serious. Today I'm talking about my my current psychosis. I'm working on Redstone computer engineering. I'm trying to build a 4-bit calculator. Can only imagine people are watching this back. And I'm talking to no one, but I suppose it's a good time to get started, and I'll stop blaring Serbia strong. Where was I? Oh, that was to test my audio earlier. Just make sure that worked. Oh, I should show you guys what I'm doing. Perfect. Here we are. Let's start from the beginning, because this is what I'm actually working on. But I want to show you my thought process, right? So basically I just started with this. And it does effectively nothing right now, which is sad, but we're gonna improve this. We're going to improve this. So this is a 7-segment display. And all it does is be on at the moment. But basically here I have each, I guess wire, we'll call it, running to the appropriate segment. So I have A, B, C, D, E, F, and G, and they're all spaced so that fortunately this contraption can power it adequately no matter where it is. Oh, I guess I should show you guys this contraption. So basically, what this contraption does is take a signal, one of 10 signals, and convert it to an actual practical number on the display. So we'll start with 0, 0 being the first bit, not 1. And you can see we have 0 on the display. We wanted to punch in 1, it would do nothing because 0 is still powered, so we have to go unpower it. And now we have 1, and it works for all the numbers. I really don't feel like demonstrating it. Frankly, that's disrespectful to you guys' time. But yeah. Of course, computers think in binary, so the next step is getting a binary signal into that. And so I found a little binary to decimal converter on the internet. I'll make sure to link it in the description. I don't see it right now, but I did get this from a video. And basically, the method is there's 2 bits of binary here. The original video was 4, but I did this for the sake of demonstrating to myself the concept, so I could copy it into this larger scheme. So you have 2 bits of binary. Oh shoot! It's not even finished. What happened? I think I might have blown it up. Okay. And so, if you guys know anything about counting binary, that's 1, right? That's 0. That's 3. And that's 4. Wait. Oh my god. I just had like a little idiot moment. Oh my god. 1, 0, 1, 2, 3, right? Because you need, what was I saying? You need 2 bits to get from 0 to 3. That's 4, right? But basically, this is the expanded version. What I've done with this so far is address, what was I saying? Oh my god. So there's 2 problems I need to address with this design. One, there's a pretty substantial delay between each digit, right? So let's say I wanted to turn it from 4 to 0, or 3 to 0. I'm going to turn those off, and you can like see that it took some time for the signal to get there, and that's because each of these takes a 2 game ticks, right, to update. And I want this to kind of work simultaneously, right? So the fewer game ticks we have delaying between each of these, the better. You see how long it took? That was like pretty substantial delay. The next problem I have is that the outputs are all spaced from each other. This one is a tougher challenge, I think. So if we take a look here, my outputs are all spaced, they're all directly next to each other. but these outputs have a space between them of 1 block, and that is by consequence of working with the repeaters. So these problems can be addressed at the same time, thankfully. So I started with, kind of started here. I kind of took a backwards to front approach with this design, but the way it works is you have the wires spaced 2 apart from each other, so that's the input. You don't have to worry about the spacing on that. But because the input we're trying to provide here is all spaced 0 blocks apart, effectively, we need to provide signal 0 blocks apart, which is part of why I chose these rails. So here's the middle, and it effectively works with the same logic as that previous one. It's a set of either 3 or 4 NOT gates, basically. So it I'm basically just saying when nothing is powered, I want only this rail to be off. And that changes this from, or that updates this block, brings the signal down. The wallstone is a little bit outside the scope of this explanation, but I'll explain it when I go to duplicating on the other side. But say I want to choose an input of 1, then I have instead this first lamp light up, because the update sees that this rail is no longer powered and moves the block. So if I want to change it to 2 instead, now I have the 2 rail no longer powered, which updates this, and you can see the output. Really going insane trying to explain this. But yeah, that's the fundamentals of what I have going on so far. It is truly a nightmare. It was a nightmare to build. So now, because this was just the proof of concept, right? I want to go take this and put it somewhere it'll actually be useful. So, looking at, we need to rotate it. Is there any way to rotate? I actually have to go check the world edit commands. Because, oh man. I'm just looking for all of the commands, because now there's something kind of comparable to world edit in vanilla mode, and I want to see if I can copy that, but yeah, it kind of looks like it's just not really robust enough, so I'm just going to do it by hand, and I can explain what I'm doing as I do it. Yeah, honestly, I don't want to deal with it. I don't want to deal with it. What are we looking at here? So we need the outputs to be on the side. I think, actually, it doesn't matter where I take an input. It just needs to be going across. So I can either do it behind the machine or going out from the machine. That's really convenient, actually, for my purposes. Okay, so it's gonna be troublesome because it's going to be a little bit off-center, I believe. Yeah, because this has to be a certain amount of blocks wide. Actually, okay, I can make this work. I can actually decrease the width. The rails only need to be 1, 2, 3, 4, 5, 6, 7, 8 across. Okay, perfect. So it's going to be a little off-center, but I don't think that'll be an issue. So let's get started. Just say, for the sake of not powering everything, we're going to start up here. So 1, 2, 3, 4, 5, 6, 7, 8. And then the 8th bit is going to be slightly outside of that, and so is the first bit. Perfect, okay. So I think I want to do my first bit. I'm going to do it here. I don't know. I'm trying to decide if the first bit goes here or here. I guess it doesn't really matter. I just chose the color conventions arbitrarily. Might as well just fucking pick one. So good, that works. Now we have to run it all the way across. These are backwards, just for the sake of my own personal consistency. Okay. Whoops. Oops. Oops. There we go. Thinking maybe I'd benefit from just giving myself night vision. Actually, this would be better off if I moved it by 1. I know this is getting really tedious, but the engineering is a lot less fun than actually showing off what I'm doing. I guess, I don't know. Kind of depends on whose perspective, because like I really like the engineering portion, probably more so than showing off any of this nonsense. But whoops, where was I? This is not anything I need. The target blocks. Yeah, actually, let's walk through the logic of why I chose the target blocks. So, fundamentally, right, I need the redstone to be in a line. Because I want to power the whole wire, but I can't take an output out of that without any sort of delay without the target blocks, which is why these are so goddamn important. I don't know. Let me see if I can explain this better. So if I power this wire, I can't take any kind of output from a block adjacent to it. But if I power this wire and use a target block adjacent to it, it's automatically redirected into that block, which powers just that. and I don't have to worry about anything interrupting it, which is insanely useful. I don't think this wouldn't be possible without it, honestly. Where was I? Am I putting it on the correct side? Oh, it needs to go in, not out. Whoops. Yeah, that's a little bit of the design philosophy there. Of course, this is the first inversion. Sound like a music theorist. All of these get inverted. Oh shoot, there's no wire running on these bits. Cool. Good. Basically, the philosophy here is, or why I chose this design of like the wires being on inconsistent levels and sort of running inward, is there's like a limited, how would you say it? There's a limited amount of distance that the signal will travel if I power it, or like powered the rail here, for example. See, that doesn't make it all the way to the end. So if I'm taking an output here, then it's not actually going to power this observer. And if I'm not getting any power, well, obviously I'm not going to be able to take my output. So there's no function. Where next? Where was I going here? Okay. Next, I need to take an output from these, which means I need to place these in a line. Actually, let's hold off on that. Because I kind of think this part's cooler. This is kind of gonna help me explain what I'm doing a little bit better. Ooh. That's wrong. Okay. Yeah, they need to level off. Okay, good. It's not gonna interfere. I think that's right. Goes over and then on top. Okay. Then same for the blue. Except I think it's this way instead. Yeah. Okay. Now, this is where we actually get from binary to 1 through 10. So, bit 1, we're going to output a pattern. We want Do we want 0 to be powered? Yeah, we want 0 to be powered. So we output a pattern like this. No, it's... What? Oh man, now I'm confused. Okay. So 0 is powered directly, and 1 is powered indirectly. Perfect, okay. I'm trying to make sure I have it right. 0 is powered directly. 1 is powered indirectly. Okay. And we're going to alternate. Bang. The reason we alternate like this, because when 1 is on, basically we want only the numbers that are basically a power of 2 plus 1, or a multiple of 2 plus 1, excuse me, to be on. And then for 2, we're going to alternate the other way. So like that. So, and then 1, 2, 2, 1, 2, 1, 2. Is that right? 2, 2, 2. I don't think that's far enough. Oh, I see the problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm taking 11 outputs. Yeah, I don't need to be taking 11 outputs. Actually, all of that should go, because I don't need it for anything. That's fine. Okay. Where was I? Okay. Now I need to alternate by 2s, except the 1s are wrong now, so. Okay. Now we're going to alternate by 1s. Okay. Now sort of we have the same thing going on. Alternate by 2s. Oops. Good. Whatever. Then we flip it. The same thing, but the other way. Okay, now this chart isn't flipped. Well, one more thing's flipped. Of course, the next one alternates in 4, the next one alternates in 8. If we were doing 5 bits, the next one would alternate in 16. I don't really know. Oh. deciding how I actually want to do the addition so far. I need a bunch of half adders. That's going to be a huge pain. Nothing's on, so we should be getting a lack of output at 0. Yeah, okay, good. And if we were to turn on 1, get a lack of output at 1. Perfect, okay, yeah. Good, I know it works now. I think we do the rails now, and I don't know, my current mentality with the rails is it's probably best to have the observer fire closer rather than further, because I can alternate the observers, but I can't alternate the rails, and I can have the power be brought down spaced out like this, which will save me a whole headache of trying to engineer a way to get it down simultaneously. Actually, oh my god, that would look really clean if I can make that happen. It would look insanely clean. Kind of lucked out with placement there, all things considered. Now, ideally, we go do it on that side, because this side, I didn't even think about this, but that's kind of the edge of my screen, and it'll just look less nice if I do it on that side. So if I can make this work. Okay, I don't really need any of these anymore. Because now we're playing around with pistons. Okay, good, yeah. I'm wondering, wall, right? I'm wondering if I need walls to be spaced out. Can I theoretically, okay. Oh yeah, that actually, oh, that's a problem. Okay, hold on. How can I avoid getting those walls to connect like that? Dang. I wonder if... No. Okay, well, change of plans in that case. We can still make this flush. This will be tricky. Let's see what I can make happen. It'd be ideal to do our odd numbers on this side. With the simple reasoning that even numbers are a huge hassle. Oh, we've encountered a problem. Wait. Actually, I can still make it flush. Sorta. Just have to use the same material. Okay. So you might already see where this is going, right? Now imagine you have this observer and notice that wall updated, right? So let's just do this for demonstration purposes. Now this wall is all flush effectively. Where am I pointing this? That way. Okay, good. I need a light. There we are. So I can demonstrate that way. But if there's something on top, it'll notice that the wall changed, the whole wall updates, which is kind of crazy. And then I can pull it off and the light turns off. The amount of mechanics in this game are genuinely nightmarish sometimes. We're on odd numbers, right? So that'll be all the way over here. So we're going to point and observe. Oh no! Wait. That can still work. Okay. So we take our observer output here. It's like less nice looking, but I think it works. Now we place our wall in. Bingo, okay. Get all of our, oops. All of our observers placed in. Okay. Oh my god, this might actually perfectly line up. Okay. Not quite. I have to go up by one. Which is fine, actually. That's not a huge deal. Not the end of the world. Now, I think only 0 should be extended right now, right? Okay. I'm actually kind of worried about something right now. Let me see how this pans out. Because I need to get a signal all the way down to here. Okay. Yeah, this is why we work backwards. Save us time in the future. So how do we get our wallstone signal? In theory, the wallstone should face this way. Okay. Oh, we've encountered another problem. This 8-bit wire, or not 8-bit, but I guess it is the 8-bit, but it's not, it's the 4th bit. That's going to interfere with my ability to send a signal down. Okay. Which means let's improvise, or readjust. Having that face the wrong way. Okay, good. Now I can send annoying and unnecessary pulses. Okay, good. Where was I? Wallstone in action, baby. Wait a minute. That's not actually powering it. God dang it. Okay. The observers need to be a touch closer. Oh, whoops. Yeah, if I face them sideways again, the same problem will happen. See what I mean? With the redstone and it not being able to connect quite right. So I think we do maybe this? That just kind of looks silly. And that way I can hopefully minimize the amount of redstone needed. Okay. So if I face a piston here, having it pointed at this block. Alright, yeah, that works. That actually does exactly what I needed to. So this is kind of a moment of truth, because I don't know if this works yet. Is it displaying 0? No, it is not. Okay. Well, should know the issue by now. Jesus. Okay. There we go. So it should be displaying 0. I now have 0 powered off, which is, again, not correct. Now it should display 0. Okay, moment of truth here. Let's put a 1 on the screen. How about a 3? Oh my god. I'm actually really excited. This is kind of embarrassing. 7? Okay. This might be worthy of debugging. So why isn't the 7th bit not lit up? I wonder if I just forgot to place a torch. Somewhere something is broken. That is to say, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this one is the one that needs to be powered, right? So for whatever reason, one of these is on. That's the one that's on. So it's a problem in the 4-bit. So, oh my god. Okay, found the problem. That's kind of embarrassing. 1, 2, 3, 4. Good. Okay. Now let's replace all the blocks I carelessly broke trying to debug. And I think that didn't work. Probably because I got double updated. Let's try it now. So 3, 7. Bingo. Okay. Let's see if we can do it sequentially because I want to see it display all the bits. So let's start with, I think that should show 0. Good. 1. Good. 2. Good. Oh wait, I didn't need to do that. 3. 4. No, I'm waiting between pulses for each one, but ideally if we just pulse them all at the same time, we can get it to display correctly. Which is probably something I should test. 5 works. 6 works. Just realized I wonder if I convert this back into decimal for the fucking the numeral panel. Oh my god. That's gonna be insane, but that's like the last of my concerns right now. So I can operate this in decimal. I want theoretically a user to be able to operate this in binary. Wait, other way around. Holy shit. Sorry, I'm kind of brain damaged. Where was I? This should be 7. Oh wait, that was 6. This is 7. Then 8. Did I do the same thing for 8? Did I forget to just power it? I should just put all the torches down at once. Yeah, but there's 8. Here's 9. Right? Yeah, that's 9. I didn't hear the pistons go. And I want to see what happens when I do 10, because at this point it will just be an overflow error. Right now, nothing is powered. Okay. So ideally, ideally we need to find a way to carry it. We need to do like a carry digit for 10. And if I want to use this at all anyways. Okay. It looks like we're only going to be able to accept 4-bit numbers at this point anyways. Unless I just want to duplicate it on the other side. It should be an insane amount of work for pretty much no reason at all. But it would enable me to... I don't know what, honestly. Would enable me to have to convert from 4-bit or from, I guess, 8-bit numbers to 2 4-bit numbers, which is like a little bit baffling. But yeah, at this point I'm gonna get an overflow anyways. So theoretically the logic connecting to this should only be able to do 1 through or 0 through 9 instead of the full hexadecimal. That would be 4-bit numbers. I guess if I wanted to do hexadecimal, I could. But like, why? What would the point be? This has got to be so far over everyone's head at this point. Hexadecimal. No. But yeah, this all looks good. This is all good stuff. I don't know where to go from here now. So I have to decide, do I want to make this 8-bit? Or do I just want to stick with 4-bit? Could do a 4-bit adder as a proof of concept on this side, which I think would probably be for the best because I don't want to try my hand at 8-bit quite yet. So we'll leave this open. In fact, I think I know what I should do. I think at this point, because we have something kind of functional, we take this and we make a backup. Let's not screw around here. There's something good going on. When I screw it up, come on, let's be reasonable here. Let's be realistic. When I screw it up, I want to have a backup. So for the time being, I say we take an overflow. So how am I going to do that? X2 from here. Whoops. Okay, yeah, that should be displaying 0 now. Good. Okay. I probably should have done literally any kind of advertising on this stream because no one's watching. I'm just talking to myself. But that's what I was forgetting to do at the beginning, wasn't it? Whoops. Whatever. This is good footage for the video that will totally come out. Okay. I feel like we gotta get some logic going here, right? I need to do some digital logic at some point. So I'm thinking we should turn, what we should do is turn, where is it? Oh, man. I don't need signs. Let's take this, just map out a little area for this. Hypothetically, anyways. Let's just like completely delude myself and say I can get it done in this space. Which is not true. It's not going to happen. But let's try it anyways. So the idea is we're going to take, I really want to do like digital logic, right? We're going to take, let's move this over a little bit just because it feels a little too close to the output, or the input side, I should say. So that's like it's kind of a chip, right? It's like a chip. The idea is I want to do digital logic and take a 4-bit number, a hexadecimal, and I want to turn it into like actual decimal, like real decimal. To do that, I have 16-bit number, so that's 1, 2, 3, 4. I'm going to turn it into decimal with 1 bit of overflow. So the idea is straightforward enough. Just do that. What we effectively need is a circuit that says if the number we have is more than 10, we convert it basically into 10 minus, or 16 minus 10, right? And then send it the overflow digit down here. This should be trivially easy. It's going to be the easiest part of this whole operation, to be honest. Running this down as an overflow, and it'll power the 1 effectively. So we get that. Let's see how far this power gets. So it gets to about here. Okay, that'll work. We can take power there and power there and run it into this part of the digit as well. Good. Okay. So now we have our overflow. I'm worried about that repeater there. I think what we should do is fundamentally waste a whole bunch of time. Whoops. Oops. I goofed. I have to completely redo the whole structure. Whoops. I'm worried about that repeater being there because we need room for logic somewhere. I think I'm too ambitious about the scope of this project. Like, I think this is going to take more than just this. So now the idea is if this exceeds where's my target block? I need that again. If it exceeds 10, so that's either 8 and 4 or 8 and 2, either of them being powered would do it. So 8 and 4 or 8 and 2 would be more than 10, or 10 or more, I should say. Target. So I can do an OR gate here. The OR gate, the not actually a gate of gates, right? I have that, which I mean, still wrong actually. This is an AND gate, so it's basically doing the addition for us. 8 and 4. Trying to figure out how to pass the 1 through. Okay, so yeah, that'll pass 1. For sure, that'll pass 1. But, or passes the 10 digit, I should say. The next part is, how do I pass 8 to the other side when this is off, but this is on? Should be another AND gate, right? So given that this signal is off and 8 is on, I need to pass every signal through uninterrupted. That goes for 8 as well, so I should figure out how I'm gonna get 8 around here. Ooh, that's a problem. I don't even need the target anymore. So that passes through uninterrupted. That passes through uninterrupted, and that passes through uninterrupted. But now we need to find an interrupt. I gotta figure out how I'm gonna, yeah, this is gonna require a whole lot more space. We should have never fooled ourselves like this. So the idea is when we've activated when we have a number bigger than 10, we need to send out a bit here. But we have our problem is that if and only if 10 is not powered, the signal can pass. So theoretically we want to delay our signal. You have to remember that you're working in 3D. So you are completely able to bring the signal down. To do math with instead of up. That was completely unnecessary, actually, because we can do this. Now we can do our AND gate. Really, really old school AND gate. Like, this is what I was learning back in, I don't know, 1.3 when I first picked up the game. Now, of course, ooh, wait, that's a problem. Consider that we've effectively made a NOT gate, and it needs to be inverted again. Okay, we need to bring back that target block. So there we have it. We have our, we can actually run this far closer now because it's just in an objectively better spot. I guess we can just bring it around, right? I know it looks like not very good, but like, does it work or does it not work, right? Works. Okay, so we've done our little adder. So now that we have it, I want to send the signal back up. Smooth. Okay, that should do it. Let's get our lever. And for the sake of it, let's turn on, what's this, 8 and 4 is 12. I should be getting an output up here. I can't really tell. So where'd the output stop? Oh, it stopped there because I forgot to place one piece of dust. Wow, this is really tedious and kind of boring. Okay, I'm thinking just a little more delay, because I can always make it less delay. I can't, it's not as easy to add delay in the middle of the circuit. How do I go about... Okay, let's think about the logic here. If... Oh wait, that's not even the right... No, that's completely backwards. Oops. Okay. Now if and only if this is off, or this is on, I want to interrupt the signal. Which will probably require torches, right? We can put targets. And it's all like, no. But if it's not all like, no, just go straight ahead. Now the problem is, hold on, let's see how this works if I... Okay, so it doesn't go down, because thankfully this prevents the signal from going backwards. Oh, that's a problem. That's still a problem. Because we need to actually interrupt the signal, right? So what I have here, that goes through. But let's say I wanted it to not. I'd have to find a way to jam it, right? Like that. Then I have to worry about the repeater timings, right? It's kind of what I wanted to not do. That's kind of why I gave this long delay to begin with, but... Maybe I need to use comparators? I don't know how, though. That could actually work. Hold on. Hold on, I didn't even think about this. So these can go. I'm thinking the way forward here is comparator. Huh? Comparator in subtractive mode. It's like almost a problem. At least it would be. Okay. I'll take this signal up. What I want it to not do is this. Put it in subtractive mode, right? And it doesn't emit anything. Okay. Say I turn the 4 off so it's less. I didn't think this through very well, did I? This needs to be a direct signal. And this looks really bad right now, but like, I'm still trying to figure out how I even want to do this. So I think this is okay. But should I turn the 4 on? What bit is even on right now? There's 2 on. Okay, so I've just really... I've ruined everything. That's why I made the backup, but I can just go back and screw with my results, so... Okay. In theory, only the 0 should be on. Okay, but like, we're just gonna have to go with the which rail is on, because that's gonna be the only meaningful way of telling until I actually complete this project. My current realization is that this doesn't leave us very much space to actually do the logic of converting the whatever you call it, right? It also leaves a little bit of signal, so I gotta be careful about that. So I'm thinking instead we put the comparator a little closer. Take a more direct output. I wonder if maybe... Ooh. That works better, okay. So instead of that, run it like this. Now I can take this, this output bit, run a redstone torch under it, and under it again. Now I have to actually connect it, I think. Doesn't really do me any good if it's not connected. Whoops. So how do I take that signal and bring it here? You just take it around. Are you for real? Oh my god. Okay. Bring it the other around. See if that works. Okay, the other round works. Good. Okay. So I successfully basically made a gate that says hey, more than 4 is lit, or more than 10 is lit, I should say. Oops. So yeah, more than 10 is lit, but if I wanted to light 1, I think that actually might be too much delay. Yeah, that works. Okay. Let's get rid of all this. So good God. Really made an insane contraption. Just step back and appreciate my work. Wow, guys. Wow, this is probably a terrible idea. That worked nice. It was not as horrible as I was expecting it to go. Okay. My new conundrum. Only time. Okay. These lights will come on whenever there's an overflow. So I effectively want to say we take the number without the 10 and the 4, right? With the 10 and the 2, that's... Okay. A little bit weirder. The 8 and the 2. Actually, they're all going to come on at the same time. What I need to do is figure out what logic will invert should be an XOR, right? Either this or this, but not both and not neither. That's 4 wide. It's got to be the most basic one, right? Okay. Blocks. Okay. Yeah, that'll work. Then 2 and 2 and... inverting this 8. The 4 can just go straight through. We're going to invert the 2, because that'll give us should give us, oops, there's 1 bit on the whole time. Should give us the inverted version. Ooh, missing something. And bring this around. All right. I don't have too much faith, but I think it should work. Display 8. Okay. Need to readjust all the redstone blocks. Pretty sure I screwed them all up at this point. 7 on this side for, I don't know how that even happened. Oh, you know what, because I didn't play with the 1 signal. That's why. So let's put a 1 on. All right. 3. Okay, 7. For the moment of truth here, 7 and 15? Oh, that's so rough. Okay. What's the story? Story is that this is extended when it shouldn't be. So where's our 5? Ooh. I could have just gone for the XOR. I don't even need the comparator. So instead of the comparator, just a set I can, yeah, okay. Comparator only needs to stop. No, actually I don't even need the comparator to stop that. Can literally just run it right through. This is kind of a dangerous move. Let's hold off on destroying those blocks. Okay, so does the 5 give an output? Oh my god, the 5 gives an output. Yeah, it was just basic XOR logic. Why didn't I not just do that? So now my display is a maximum of 15 instead of it's a maximum display of 15 instead of 9. Awesome. Alright. We've got some compacting work to do now that we've figured out the theory. So 2 XOR gates on the 8 and the 2. Otherwise, the bits can just go straight through. Okay, that works. think I should call it a night, but like... Oh my god. No, I think I can do this better. Every time I am bored. What the hell? Give me something to work with here. Okay, I'm actually kind of worried about destroying like more useful parts of this. But yeah, this should be extremely capable, extremely simple. Oh, fuck. Oh, thank God. Okay. No more of this. Gonna really destroy something if I keep screwing around with TNT. Okay. So there are 2 gates we need. We need 8 and 4 are 2, and we need that output XOR 8 and XOR 2. Okay. The only thing we really need to keep is the wiring on the gate. The minute I figure it out, I'm like, let's blow it up and do it better. Actually, that maybe it's a good instinct to have. Let's do it better this time. Okay. Probably far simpler to do XOR gates like this. My worry here is that how do you do that? There's the comparator XOR. I really want to limit the tick requirement. Okay. The smallest possible XOR. Okay. I like that. 2 observers, 1 block, 1 copper, what do you call it? Bulb. Waxed, waste, waxed. Huh. The heck? Oh my god. Have I gone completely crazy? Where is it? It's... Why is it not here? Oh my god. I'm running this world on 1.20 and not 1.21. Okay, back to the comparator idea. I'll upgrade that later. It's worth a shot. Not today. I don't think that's gonna work. Unironically, the old school one was significantly smaller. But I really like that new one. Okay, guys. We're gonna lose out on Optifine, but might be worth upgrading the world, actually. Yeah, let's do that. We're gonna. I can't turn on experimental features from. Okay, we're gonna make another backup. Okay. Let's open the new version. I won't be able to use my fun, cool shaders anymore, but I feel like that was more distracting than anything. It's fine, it's fine. Okay. Wow. Wow, I'm dumb. Okay. Back to the game. Is that really all? Block, server, I'm worried about the observerness of this. I don't know if there's a better way to say it, but you see what I mean? I already am pushing blocks I don't want to be. Let's just disconnect it. Let's see what it looks like. That can't be right. Failed asynchronous. Just have to make sure they're desynchronous, right? We do need an observer. Not observer. A comparator. I don't need the wall anymore. Okay, that works. worried about here, it's nice and small, but it will break with synchronous inputs. So I just upgraded for really no goddamn reason at all. Be a better way about this. And that didn't make any sense to do. I've gone from something that makes sense to trying to reinvent the wheel, and that's a huge problem. I'm back to 4 wide, so why did I even bother? Well, it actually works in theory. But it doesn't work in practice. Subtractive. No output. 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 Really reinventing the wheel here. Okay, on, off, not off. And it's back to 4 wide, so why did I bother? Okay. That last one had a speed of 2, right? Just use the classic one. Yeah, no point at all trying to reinvent the wheel, right? I don't know. Maybe I should just call it, because the old one clearly seemed to work. Okay. Bang, bang, bang. 2. I think I'm going to stop streaming, and it's mostly because I've run out of things to say, and I'm just exhausted. But, thanks for watching, anyone who actually did tune in. I don't think anyone did. Yeah. Chat's dead. There's only good footage for... I don't know, actually.